Hello and welcome to University College Dublin, where we're broadcasting live this Hangout on air. Today we're going to spend about 15 to 20 minutes discussing the UCD MSc in Space Science and Technology. Some of you may have seen a 30-second video as part of our graduate marketing campaign. That video features a prominent UCD academic and researcher, Professor Lorraine Hanlon, talking about one area of her research and expertise. Professor Hanlon is joining us on the Hangout today to talk a little bit more about her research and how it relates to the Master's programme and what students can learn. Also joining us on the Hangout is one prior student of the programme, Daniel Vag, who's a Master's graduate of the programme, who's now actually working in a spin-out company that relates to the programme. So he'll tell you a little bit more about that. And also joining us is Conor O'Toole, a current student of the Master's programme. So thank you all for joining us. I'm going to hand first to Professor Hanlon to talk about her research and the Master's programme.
So I just wanted to say a few words to maybe introduce what I do. My research is in high-energy astrophysics, usually from space-based instruments. The reason we do that is because our atmosphere blocks gamma radiation from reaching Earth, so it's almost impossible to do gamma ray astronomy from Earth, and that's the highest energies can detect in the electromagnetic spectrum. And it's radiation that's typically associated with very violent processes in the universe, such as stellar collapse, massive stellar collapse to produce gamma ray bursts, and or the coalescence of two neutron stars to form black holes, and so on. So these very exotic, I suppose, processes are amenable to study through gamma radiation from space. And that's what I've worked on for about 20 years now, first at the European Space Agency in their research centre in the Netherlands. And then after that I came back to Dublin and I've pursued that work with colleagues here since then. And I think as part of our research program, we're very conscious of the training aspects for our graduate students. So we've developed quite a significant program in instrumentation development and telescope development. So we've built a small robotic telescope in South Africa that looks at the optical fading emission from these gamma ray burst explosions. That's called Watcher. And that's been, I think, a really important part of our work for the last few years, that we're not just relying on data coming from instruments in space, but we can build our own instruments to do our science. And then finally, in the last few years, we've developed an instrumentation detector program with ESA, essentially trying to look at new technologies for the next generation of gamma ray instrumentation that we might fly in space. And as you can imagine, this is a long time scale program, because it can take many years, if not decades, for a mission to go from initial planning and proposal phase actually into full launch and science data taking. So those are some of the strands of the work we do. It involves collaboration with engineering, very much material scientists, electronics engineers, as well as our astrophysics colleagues around the world. And I suppose that's kind of inspired us, our work has inspired us to develop this master's program, because our collaborators all include industry. And we kept hearing from industry collaborators that they couldn't get people with the right skills to work in their companies, that they had to spend a lot of time training engineering or science or computer science graduates to understand the issues around working in space and developing instruments for space. So in partnership with Irish Industries, we came up with this concept several years ago to really have a program that was tailored not just to the astrophysics side of my interest, but also to the importance of mapping out skills that would be in demand by the space industry for graduates on completion of the program.
Okay. Thank you very much, Lorraine. And actually, we have a question in about careers and the industry connections. Could you speak for a moment about some of the specific companies or collaborators that the program coordinates with?
Yeah, absolutely. So as I said, the industry component was crucial to developing the curriculum. So we have embedded in our curriculum key skills that we heard from industry that they required of graduates who do the program. So I suppose we have three big industry partners so far. Two are US multinationals, in fact, who now have bases in Dublin. One is Moog, which is a US multinational with many as to its operation, but a space aspect. And they are heavily involved in, for example, the launchers program, and vibration control is a big activity in their Dublin operation. And they also have a Cork operation as well. And then our other partner is Curtiss-Wright, who are pioneer, obviously in flight, coming from the Wright brothers, but now in space flight as well. So they develop avionics control systems also for aviation, but typically and growingly from their Dublin base in aerospace and space. So they've had first flights on SpaceX capsules on the Falcon, and they're very close to UCD, so physically as well, which is great. So Dan can talk maybe a little bit more, since he did his industry placement last year with Curtiss-Wright. He can talk a little bit more about their activities. Our third partner is based in UCD. It's a UCD campus company called NBio, and NBio are pioneering new surfaces for extreme temperature control. So essentially what they're trying to do, and have done, is develop a heat shield for a space mission called Solar Orbiter that the European Space Agency is going to launch in 2018. It's going to go closer to the sun than any previous space mission, and it's really hot, which is very, very bad for your science instruments. So NBio have won significant contracts with ESA to develop their technology as a heat shield for Solar Orbiter and various parts of Solar Orbiter. And again, that's been developed in conjunction with people from engineering in UCD as well. So they've supported a lot of the work we're doing, and also are very encouraging of students to placements with them as part of their exciting program. And they just opened, I should say, a new production facility down in Clonmel in Tipperary, where they're going to be manufacturing the production part for Solar Orbiter. And then internationally, just to go back to your question, internationally we're collaborating obviously with the European Space Agency very heavily, and we have a spin-out company that has grown, if you like, from our astronomy research into data mining of space-based space archives of data. And that's with collaborators all over Europe, but mainly at the European Space Astronomy Centre in Madrid. With Sheila McBreen, who's a lecturer in the department and School of Physics, she has a lot of collaborations with NASA, in particular on the Fermi satellite. She's a member of the Fermi satellite team, which is a high-energy instrument currently in orbit. And a number of our graduate students spend a lot of time actually at NASA in Huntsville in Alabama working on Fermi data. So that's just a snapshot of some of the work we do.
Thank you very much, Lorraine. So from the European Space Agency to NASA to domestic spin-outs that start here in UCD and go out further than the world, this program can offer quite a lot of opportunities to students. I see a question here from Anjana. Anjana, I'm going to come back to that in a couple of minutes. I'll put your question to Lorraine. But first, I think we'd like to introduce Daniel Vag, who finished the master's program and went directly into one of the type of spin-outs that Lorraine has mentioned. So I'm going to hand over to you now, Daniel. I'd like you to just tell us a little bit perhaps about why you chose to study the master's at UCD, and what led you into doing what you're doing now and what you hope to do next. So over to you, please, Daniel.
Sure. So back, I think my undergrad, I was doing physics with computing. During that, similarly to this master's degree, there was an internship opportunity where I worked with a company called Pete Henry and a company called, well, not a company, but ESTEC. So I was working with the Technology and Research Center of ESA. In there, I worked with a satellite, and I began to develop an interest for space science and technology. I then worked full-time with Pete Henry afterwards for nearly 3 years, which is just one of the benefits of internships and having industry connections from your degree. And I decided I wanted to advance my space physics area. There was a toss-up between that and quantum mechanics, but I think space is a bit nicer. So I heard of the UCD Space Science Master's Program that had just started, I think, when I applied. So I'm one of the first through it. And yeah, that's why I chose it. Just had a previous interest in it from previous internship. So the degree is very, well, in my opinion, is very good. One of the things I like about the degree is that you learn a lot of different disciplines. Like you go from the space environment to launchers to different types of rocket systems and different types of engines that can be used, orbit analysis, but they all work together. Like there's some electives you can take as well. One elective I took was it was provided by Trinity in plasma physics, and that fed into the kind of the space environment, and then you start understanding the things like Aurora, and you get into really in-depth mechanical understandings of really advanced things like plasma thrusters, which is really cool, in my opinion. So yeah, that was leading me up to the masters, and then for the final third semester, there was an industry placement opportunity where I worked with Curtis Wright, as mentioned earlier, who do the avionics testing equipment, but they do the actual stuff that goes onto the launchers for SpaceX and different types of capsules for the European Space Agency. But it's not like Curtis Wright as a whole do this. They're a large, very large multinational. But it's actually the office in Dublin beside UCD that do this hardware. They manufacture it all upstairs, and it's just them that do it really. So yeah, it was very interesting to get to see that, you know, a small company in Dublin, a small office in Dublin from a large company is building such important stuff for kind of the cutting edge of space science. So I worked with them, and then I worked for a short contract with them afterwards, and then I was introduced to ESA, I suppose, a bit, and now I'm working as a system architect in parameter space, where we're building interesting data analysis systems for a growing problem in science where data is just too big. So Gaia satellite, which is one of the most interesting satellites in ESA, it's going to track 1 billion stars, but also not only find their positions, but find spectral information about them, and a lot of other science. But there's 1 petabyte of data. If you stack that on DVDs, you get 267.6 meters of height. That's how much data there is involved in this. So you can't download that. You can try, but you won't finish it. So you have to kind of design a new data analysis system for that. And that's what we're doing. And we'll also be one of the first to use it. So that's a bit for me anyway.
Thank you very much, Daniel. We might come back to you with one of the questions in a moment. So from what I can understand, you're not just helping to gather almost infinite levels of data and to make it usable, you're also having to, you're capable of analysing it in a way that perhaps has never been done before. And thank you for the visualization as well with the CDs, that's pretty mind-boggling. And before I hand over to Connor, I just have one question here that I'd like to put to Lorraine. And Lorraine, that is, does this course include a master's thesis? And if so, what is the duration, please?
Yeah, it does include a thesis, and the structure is flexible. So you can have, so it's 90 credits in total. 60 credits are taught, and 30 credits research or industry placement. Or you can have 45 credits taught, 45 credits research. So you decide in conjunction with the staff on the program what option is best suited for you. And that research project takes place in the 3rd semester, in the summer semester. So it's 12 months full-time for the master's program if you do it as a full-time option.
Okay. And can I ask you to just, for those who choose the research thesis option, what sort of topics do they tend to focus on for their research?
Well, maybe Connor can talk a little bit about what he's going to do his thesis on in a second. So it's a mixture. I mean, a lot of the students on the program so far have opted for the industry placement, which we fully support, of course. But in the department, then, if people were more interested maybe in doing a research project, for example, in astrophysics, they could work with one of 4 or 5 colleagues in astrophysics, so on theory, if they wanted, or on data analysis, data mining, on software development for space, lots of different aspects of astrophysical research. Or they could work, for example, with colleagues in engineering on an engineering type materials project as their research thesis. So it is flexible, and essentially the students' interest can drive a lot of the direction that the research goes into.
Okay. Thanks very much, Lorraine. So as prospective students, hopefully will take from that there is quite a lot of flexibility in terms of choices, whether one would like to do an industry placement and start building their career in that way, or focus on a specific aspect of research and work with UCD's expert academics as their supervisors to help them with that specialisation. I'm now going to hand over to our current student of the Master's Programme, Conor O'Toole. Conor, perhaps you'd tell us a little bit about why you chose to study on this Master's Programme at UCD, perhaps mention some of the modules that you've studied, and if you could tell us what you're working on now as you come to the conclusion of the Master's Programme. So, Conor, I think I have you on mute. Apologies, so let me unmute you and bring you up. Okay, yeah, you're ready to go. Yeah.
Okay, thanks, Lisa. So I came into this course from a maths degree, Internship. But during that degree, I had done a lot of theoretical physics and got really interested in space science, particularly general relativity, during the course of my degree. When I came into this, I had almost no lab experience or coding experience, but through doing a lot of the core modules in this course, which involve using gamma ray detectors and building a CANSAT, built up a lot of those skills. I chose the shorter internship, which meant I took a lot of electives, which included astrophysics and cosmology and a planetary geomorphology module that I found really, really interesting. So I got to build up a lot of the other skills that I wouldn't have gotten in the theory-heavy degree that I had done beforehand. Now coming up to my internship, which is going to be in the Ames Research Center, NASA's Ames Research Center in California. The project I'll be working on is using CubeSat technology to build small submersibles that you could send to the icy bodies in the solar system that are thought to have liquid oceans. Just to answer as well that question that was fielded about the type of topics that the people work on for their thesis. The other 2 guys in the course with me, one of them is actually working in NBio, currently, the company Lorraine talked about. The other guy is working in ESA, looking at building or a paper study on how to build moon bases using 3D printing. So there's a lot of really interesting ideas that seem a lot like science fiction, but you're actually getting to a point nowadays where we're working on them as well. So I think it's a really interesting time, definitely, to be getting into the area as well. And this course was definitely a big leg up. I don't think any of us would have gotten those opportunities if we hadn't been in it.
Thank you very much, Conor. I believe you just said moon bases, building moon bases with 3D printing. That's incredible. Yeah. That really is the stuff of science fiction. I'm going to check whether we have any last questions and answers before we start to draw this session to a close. No final questions at the moment, so I'm just going to check whether Lorraine would like to add any final thoughts before I talk about how to apply for the program. Lorraine, have you any final thoughts that you'd like to add?
I mean, I'd just like to echo Connor's point there that it really is a great time to be getting into the space business. You know, so much of our communication and navigation tools are space-based now with GPS and sat-navs and so on. And obviously mobile phones and so on. So, you know, not only that, then the Earth observation gives us this perspective on the planet that I think is becoming more and more important, managing resources on the planet and observing and mitigating damage to the various habitats on Earth. So, you know, as well as the very exotic sci-fi element to it, there's an awful lot of our everyday life now that really relies on the use of space. So I think it is a great time. I think it's only going to become more important in what we do, both from astrophysics point of view, from a remote sensing Earth observation point of view, and from the engineering point of view as well. So any further questions, you know, I can be contacted by email. I think you'll put up the details shortly.
Yeah. Thank you very much, Lorraine. I think that gives a really good context for what some might perceive to be a niche or a specialist area actually has implications for lots of different aspects of our daily lives and will be increasingly important going forward. So we would hope that there are, you know, as well as at the master's level, people who are already thinking forward to their career, we hope perhaps some younger people might watch this video and think actually getting into science and getting into this aspect of physics and science when they're a little bit older could be a very, very exciting way to go. Just before I conclude, Daniel, I might ask you to just give a word on the type of students who might consider applying for this kind of master's who perhaps mightn't have given a consideration up until now, if you wouldn't mind.
Ooh. There's a lot of different types of students to think about. I suppose one thing with physics, like when you have an association with physics, some students worry that it's going to be very intensive mathematically, and while there are some math elements, it's not as daunting as you might think initially. The lecturers give plenty of help there. There's always resources on university, you know, to help you out if you have a problem there. But it's really, I suppose it's sort of unique in space science because you're applying these concepts to space, and it's, I don't know, it just doesn't seem as mathematically scary as it is. Well, when you're in it, it's fine. Like you're applying concepts on geomorphology to Mars. You know, you're looking for ice caps. You're trying to quantify the level of carbon dioxide, you know, pure water in Mars. So I'd say it's not just physicists who should apply to this. I think we had a mathematician in our year, I think. I'm pretty sure he was maths, primarily maths, and he really enjoyed it. He came out well with it. I don't know. I'd say physics mathematicians, but like I have a few people from industry who are now contacting me asking me about modules in the space science degree. And they don't have recent experience in university. They want to know about certain areas of space science, and it's a great degree for that. I mean, the information is really applicable, really useful in industry. I seem to be rambling a bit. So, is there any particular area that you want me to?
No, that's perfect. Thank you very much. I just thought it would be useful to get a student's perspective, because again, some people might perceive that this area might be so specialized that it wouldn't be open to them, whereas in fact there could be big opportunities there for them. And thank you for helping me, who did not know what geomorphology was, to now understand it a bit better.
Wow.
What I'm going to do now is I'm going to put up a little slide, and this slide explains how people who would be interested in the program can get in touch. Okay, so to directly apply, you can go to ucd.ie/apply, and the course code is F060. For any academic queries, you can directly contact our course director, Dr. Deirdre Coffey, who wasn't available to join us on the Hangout today, but is absolutely available for queries. Her email, sorry, I should have put up there, is deirdre.coffey@ucd.ie. For administrative type queries, you can contact the UCD student desk, and the URL for that is there. And we've also included a link to the program brochure for this particular Masters in Space Science and Technology, so you can read a little bit more about it on there as well. Thank you all very much for joining our Hangout today. We enjoyed talking about the Masters in a little bit more detail. Actually, we have one final question in, so before I close, I might come back to Lorraine, if you don't mind. And Lorraine, I'm going to put this question to you, and that is an engineering degree sufficient enough for this course, as the curriculum is mostly physics-based?
Absolutely, yeah. It's open to all STEM graduates, science, technology, engineering, mathematics. Without a doubt, it's not as heavily physics-based as you might imagine. So there's a couple of core modules in the first semester, one on the space environment and one on applications of space. So they cross-discipline. We have lecturers from engineering who talk about the telecoms aspects, lecturers from the meteorological service who talk about the remote sensing aspects. Connor and Dan taught a little bit about the planetary geomorphology. That's a module that's run by the Department of Geography. So the core modules are not necessarily totally physics heavy once you have a reasonable background in a science, technology, engineering, or maths discipline.
Brilliant. Thank you very much.
Welcome, engineering graduates.
Just so now that there you go, Anjana, you are welcome. And one last question from Anne. She's asking how many students are typically on the master's program every year?
So we just started last year. You've got Dan and Connor from years 1 and 2, and we've had basically a handful of students both years. But I can report we have very high interest this year. So we're really hoping to grow the number to about 15 students or so.
Okay, thank you very much, Lorraine. That we just had those couple of last questions in there, so I'm glad that we were able to answer them. And just to conclude, I'm just going to put that slide up again so anyone who's interested can find out how to apply. Thank you very much to all our panel members today for taking part in our Hangout, and we hope that it was informative to you.
Thanks.
Thank you. I'm going to leave that slide up there for another minute, and we can all bow out. So goodbye from Lisa Flannery, UCD Marketing Manager.